This example will show some of the important items to consider when modeling walls with discontinuities. This is the model that we will use, a planar wall with an offset at the first level. The load on the model will be a static earthquake lateral load. In etabs, planar walls are typically modeled as single objects, and it is the connectivity and behavior at the offset corners that is of particular interest. We will do a total of 4 analyses. In the first analysis, we will use a refined mesh with no edge constraints. This will be the standard for comparison. In the second model, we will use a semi-refined mesh with connectivity at the corners along with edge constraints. In the third analysis, we will use a coarse mesh with no continuity and edge constraints. In the last analysis, we will use a coarse mesh but no line constraints. For the first analysis, we will select all of the wall objects and assign an internal mesh of 1 by 5. We reselect the wall objects and turn off the line constraints option. If we go to the View Options command, we can view the mesh on screen. Note that the mesh lines up not only at the corners, but that all of the interior mesh lines are continuous. Next, we run the analysis, and a right-click on a top joint shows a displacement of 0.04. Note this for further reference. A plot of the forces in the wall shows a pattern that seems appropriate, with the expected concentrations around the corners. In the next analysis, we will use a mesh that does not line up in the interior region, but does provide connectivity at the corners. This connectivity at the corners is very important. We select an object and assign line constraints. Making sure that the Apply to Full structure is checked. Running the analysis this time gives a displacement approximately 10% stiffer than that for the refined mesh without line constraints. And a force plot that still seems reasonable. This model is an effective use of the line constraint option. In the third analysis, we will assign a nominal mesh of 1 by 2 to all the wall objects. In this case, neither the corners nor interior regions have mesh continuity. We will also activate the line constraints option for this model. Although the displaced shape looks reasonable, we see that the displacement is approximately half that of the first model, meaning it is twice as stiff. In addition, a check of the force distribution shows a pattern that does not intuitively match what is expected at the wall corners. This model is much less accurate than the first 2 cases. In the last analysis, we will again assign a coarse mesh that does not offer any continuity between the offset wall objects. In addition, we will also turn off the line constraints option. This results in a structure that is unstable, which is verified by a check of the displacement. This is not an appropriate model. Reviewing our results, the first two models give acceptable results, while the last two do not. In conclusion, the line and edge constraints option is a powerful feature for connecting dissimilar meshes and walls, and works well when mesh connectivity is provided at discontinuous corners. However, using line constraints without proper meshing will result in a model with an incorrect stiffness.